Yay. If all goes well, we're live.
Okay.
That
Let's
is.
see if someone notices us and says anything.
Where's Eddie?
He's right here beside me on the floor.
Oh, good. Don't pay any attention to him, though, or he'll jump up and.
Exactly. Well, he's currently asleep. So I got smart and I learned to give him a tasty caloric will nap after he eats it treat about an hour
Wow.
before we record.
Oh, really? Nice.
So,
Drugs.
yeah, well, more like food coma.
Food coma.
Yes.
Uh,
Food coma for the dog.
oh, what's going on? What's happening?
Just plowing through. I just got back from giving a talk at Goddard, and before that, I was out in Arizona working on writing a report. And now I'm home long enough to do laundry, and it's exciting. And I'm very grateful that the weather changed 30 degrees because it meant I had clean clothes because it was a different climate suddenly.
What did they want you to talk about out at Goddard?
CosmoQuest, citizen
Wow.
science, our server system, all that sort of stuff.
That's fantastic.
So yeah, I was hosted by Nargis, who's one of the programming pipeline teams, and she was an absolutely great host. And I got the most delightful tour of the Hubble Space Telescope control rooms, which are now utterly empty because the whole system is automated, whereas they used to have human beings sitting there typing in
Right. Otherwise,
commands.
it'd just be a bunch of robots working
Yeah,
controls. Yeah.
so it was a good trip, and I got to see Moon Ranger Laura, who's a friend who works out there at Goddard, and life is good.
I say hi to a bunch of people. Ash Boone, Bill Kay, Blair Pigeon, Baruch Kleincar, David Trogue, Eric Knapp, Giselle Saberman, Gordon Dewis, H. Roll, Harry Patrick, John Drake, John Morrison, John Suffield, Nancy Graziano, Nichols of the Yard, Psycho at 749, Tack Tang, Thomas Traniker, Tom McIntyre, and Zap Fan. Hey, everybody. Welcome to Astronomy Cast. So, based on what happened last week, I've decided, as I do, that the full feed of what we do here on Astronomy Cast during doing the full video should become a podcast as well. So Susie's madly working away, and hopefully within a couple of weeks we will have a full feed, audio feed. So if you want to hear the shenanigans, the whole thing, just the sausage making in all its excruciating glory, then you'll be able to while you're walking your dog, as opposed to having to watch on YouTube,
Exactly.
which is good. I It's funny. I'm sort of going through this process where I'm trying to sort of figure out all of the places where I communicate the projects that I'm working on, and it turns out that I have 60. That my personal Instagram channel, my YouTube channel, the Astronomy Cast, the full
Yeah.
feed of the weekly Space Hangout audio feed, et cetera, et cetera, et cetera. And needless to say, with that many different channels, it's rough to actually get the all the information out there. And as we sort of add more of these channels, it's just, man, it's crazy. Glad we've got a big team and a lot of people to help us out, because
Well, and we both evolve habits because I remember for years I was on Twitter and you were like, I am not going to be on Twitter. And then you like very quickly overcame everyone on Twitter because that's what you
that's
do.
once I decide a thing that I want to do, then I show up.
And I keep trying to use Twitter like Instagram and post photos there. And you've been telling me to actually use Instagram. So I'm going to be putting a sticker on my phone that basically says Instagram exclamation mark and
Perfect.
hopefully changing my habits.
Instagram's a fun one. I think I've mentioned this in the past, right? That if I had to only pick one social media network, I would just use Instagram. I really enjoy it. Just for the simplicity, just post a picture and go, I took this, and then that's all you have to do.
I just wish it had a desktop interface.
Yes. Yeah, I mean,
That's why I don't use it is because
yep.
I try and do as much as I can from a desktop due to carpal tunnel, and it's just like Instagram. You're insisting that I experience pain.
There is no well, there's no way to post a picture to Instagram without using a mobile device. But there's some workarounds so that you can literally just press like 3 times and a picture goes up into the
Yeah.
Instagram feed, and you know, on your phone. So it can be made fairly easy, but yeah, absolutely, I totally agree. I really enjoy the even the live feed. Like, it's super
Yeah.
fun to just go on and take questions. No, I don't believe in aliens. No, I don't believe in aliens. No, I don't believe in aliens. You know, that's sort of the way it goes. But it's a whole different audience, actually. It's pretty funny.
You were turning Instagram into a Skinner box. It's kind of delightful to watch.
Apologize. It looks like I'm getting a couple of dropped frames. So I just restarted my router, so that can't be it. Anyway, I hope it looks like it's okay though. So if you have no idea what it is that you've stumbled into, we are about to do a live episode of Astronomy Cast. This is, of course, our weekly facts-based journey through the cosmos. We're going to continue on our what do we call this? Our mini series on destruction and renewal. This week we're going to be talking about tsunamis, which I can already see Pamela is giddy at the massive devastation of this. So, yeah.
I tweeted earlier, come for the science, stay for the death and destruction.
Perfect. Twitter. Oh, I forgot to tweet. Oh, see? See? That's what I'm telling you. 60 things. Okay. So, we'll take whatever time I decide to do the show, and then at that point we will wrap this up, and then we will stick around and answer your questions about space and astronomy or Instagram, whatever. Yeah, my stream is unhappy, sad. Well, it'll make it. It'll do it.
Okay.
All right. I'm ready to record if you're ready to record.
I appear to be ready to record. I am pressing record. I have pressed record. Hello, Chad.
Hello, Chad. This is for you. Here we go. Astronomy Cast, episode 443, Tsunamis. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, the Director of Technology and Citizen Science at the Astronomical Society of the Pacific and the Director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well, and I have to congratulate you on getting my title completely right on the first try.
You have a very impressive title. The longer the title, the sort of
more space it takes up on a grant application, irritating me later.
yeah, exactly. But no, I mean, you've earned every word of that title, Pamela.
Thank you.
Do you have anything to shamelessly self-promote this week, or should we just get started?
We are gearing up for Citizen Science Day in April. So follow along at cosmoquest.org starting on Monday as we begin our countdown to great new things that just might begin with the letter H or I or both.
I don't know what it could be.
Stay tuned on Monday.
All right. One quick thing. I just did a collaboration video with Dr. Paul Matsetter. He's one of the people from the Weekly Space Hangout. And just as you may know, Paul and I are going to be going to Iceland in February. Spaces are filling up pretty quick. I think there's now a pretty big list of people that are interested. Got till August to put down your deposit and agree that you're going to come with us. I think it's going to be the trip of a lifetime. Personally, I can't wait to go. But if this is a thing that you want to do, you should go to astrotouring.com and you can find out more. All right, let's get going. Surf's up. Today, we're going to be talking about one of the most devastating natural disasters out there, tsunamis. We're talking huge waves that wreck the seashore, but it turns out there are many ways you can get a tsunami, and one of those does have to do with space. All right, Pamela, what's a tsunami?
It is basically the Japanese translation, harbor wave. It is, my audio feed just stopped. Audio feed, why did you just stop?
You mean your recording stopped?
Yeah, at 2 minutes, 23 seconds. And I have a whirly rainbow. And now it's caught up. Okay. I'm going to re-answer that question.
Sorry, Chad.
Yeah. I did order a new computer, so hopefully we'll have this problem less. Okay, starting over. A tsunami is, directly translated from the Japanese, a harbor wave. It is a wave that is pretty much imperceptible out in the deep oceans, but as it approaches the shallows of a harbor, you suddenly end up with this giant wall of water that can be tens of meters high.
Right. And, it's a Japanese word, but these things happen all around the world. What is the sort of the cause of a tsunami?
The simplest way of putting it is it's a giant splash. It is a giant seashore destroying horrendous splash. Anytime you displace water, you create a wave. Drop a rock into the water, splash it with your hand, thump upwards the ground underneath the ocean or a pond or a lake. Anything that compresses, moves, displaces the water is going to cause a wave. And if you do this just right, it causes a giant destructive wave.
But I think the thing that's most fascinating about the tsunami is how far this wave can travel. Right? You can have an event on one continent and it generates tsunamis half a world away.
So we were almost late recording today because I went down a rabbit hole about exactly this. Back in 1700, there was a massive Cascadia earthquake. They've actually figured out it was exactly in January of 1700. And the way they figured this out was because the tsunami tied to this Cascadia. So like your part of...
Yeah, that sounds like a really scary place to live. Who'd want to live there?
Right, exactly. That was kind of my reaction. So there was this amazing tsunami in January of 1700 that caused a tsunami that had long perplexed Japanese historians because about 12 hours later, it hit and destroyed a 600-mile long swath of the Japanese coast.
Oh.
Yeah.
Yeah. So that is, we made the earthquake, and then it made it all the way across the Pacific Ocean and smashed into Japan and caused devastation there. Thousands and thousands of kilometers away.
And the kinds of displacements of land that we're talking about is there were areas of forest along the northwest coastline that suddenly plummeted in height so much that they ended up submerged below sea level. And this caused massive pockets of what are now called ghost forests, these places where we can tell there was a forest there. And then seawater kills trees, and thanks to dendrology, the ability to use tree rings to figure out when things happened, it was realized all of these trees died in the winter between 1699's end of summer and the beginning of spring in 1700. This was step one. Step two was looking at the Japanese records, and they had excellent written records in Japan because they had a written language there, and records of the Orphan earthquake there, put the pieces together. And this is part of how we learned that Cascadia is a very unstable place.
Should I move, maybe?
Yes.
Okay. No, it's not going to happen. We're
You're
not
good for
due.
a couple hundred years.
We're not due, right?
Not yet. No, this is one of those fault lines that appears to build up pressure for about 500 years or so, and then fire, release all that built up pressure. And we're only about 317 years in. You're good.
Okay.
You're good.
All right. Good. But so this is one source of a tsunami, a gigantic earthquake.
Yes.
What are some other sources of a tsunami?
So you have this giant momentary, everything shakes, everything plummets or rises kind of earthquakes. We had this in Cascadia. Similar things have been seen at the end of the Minoan culture, happening in Crete, happening along the Chilean coast. But then there's another kind of earthquake event that is completely terrifying because you have a slow earthquake. This is an earthquake where you don't get this massive, suddenly everything is rocking and rolling. You instead get a slower, lower magnitude earthquake that, because of the way it gives off its energy slowly, can cause a disproportionately massive tsunami. So, still earthquake related, but slightly different. And it's important to know you can get tsunamis from massive earthquakes. This had been well known for thousands of years, but realizing you can also get massive tsunamis from wussy earthquakes was a lesson learned the hard way. Unfortunately, in Japan, when they on a holiday had a minor earthquake during celebrations, and because it was a minor earthquake, because it was during celebrations, no one sought cover, and this actually led to a lot of standing stones being built to record "Do not live below this standing stone."
Wow.
Yeah.
So that's one form, was the earthquake, the super violent, huge earthquakes, and also the sort of slower ones, as long as you're getting water displaced. Possibly the most devastating ones are landslides.
Yes. Now, luckily, these don't seem to occur quite so often. There have been a few examples up along the Norwegian coast, for instance, sending tsunamis roiling across to head towards the British Isles and do bad things there in Scotland and Ireland. But luckily, the landslides are less common. So we get issues tied to volcanoes as well, where it's this mix of the volcano and the landslide, and it's hard to decouple which was which. But again, it's basically a giant splash. You throw rocks, in this case, an entire coastline, into the ocean, and out goes the wave.
And some of the biggest ones, I mean, some of the biggest tsunamis have been from these landslides. And I know there was one in Hawaii that I think pushed seashells like 1,000, I'm trying to think, like hundreds of meters up onto another island, that every now and then huge chunks of Hawaii just shear off and splash the nearby islands.
And this has to do with a combination of, again, volcanoes and also just the slopes. This is completely new land, and any of you who've ever built a sandcastle know that if you have that angle of incline on the side of the sandcastle too steep, as you add dirt, it's just going to start rolling down. Well, volcanoes kind of can have the same problem now and then. They're excreting lava, for lack of a better phrase, and as that lava builds up, you get these steep angles if you have just the wrong viscosity, and things shear off.
Folks in the chat are talking about the Canary Islands as well as another situation where you've got this gigantic landslide that is inevitably going to shear off and just send a huge splash into the water nearby. Okay, so and then let's talk about the space source.
Oh yeah. So this is one of those things that we don't actually have any written historic records of happening, but oh my goodness, we have amazing computer models. And a lot of these amazing computer models were inspired, you might say, by the asteroid Apophis, which looked like it just might, but we now know it's probably not, looked like it just might make an impact into the Pacific Ocean. And when we ran these computer models, it turns out that when you impact the ocean, it's sort of like throwing a giant rock into your swimming pool, but you take all the water in the column that's the diameter of the rock, you remove it, push it sideways all the way down to the bottom of the pool, except you're doing that where our pool is the Pacific Ocean.
Yeah.
And then not only do you have the displacement factor, but you also have the heat energy, the kinetic energy, all of this that's also getting added into the system. So you have multiple causes for the water to get displaced, and displaced water has to go somewhere. Some of it will crash back in, but a whole lot of it will do things like, well, in the models we had for Apophis hitting, uh, remove everything west of the Rockies.
Right. A tsunami that would scour everything to the Rockies.
Yes,
Ugh,
it's glorious.
you monster. Um so then, okay, so let's talk a bit about then, you know, in our imagination, a tsunami is like this. You look over off to the horizon and you see this gigantic wave, like a big breaking wave, and then it hits and surfs up. But that's not what people who are on the ground experience when they have that, when a tsunami hits your area. What happens?
It's really terrifying, especially in fishing communities, because there's record after record after record of the Japanese fishing villages, the Indonesian fishing villages, the Mediterranean fishing villages. You have the fishermen, women going out to sea in their boats, and nothing's amiss. And they're out just out of sight of the shore, and they come back, and there's massive destruction. And a few people may be left up on high land who describe one of two things: either the wave comes absolutely out of nowhere, or there's this amazing pulling back
Yeah, yeah.
of the water. And the horrifying thing I didn't know until I prepped for the show is you don't always get that pulling back of the
Mm,
water. And this is because when the tsunami is created on one side of, it's often a subduction zone earthquake. On one side of the subduction zone earthquake, you have the water going on the upside of the wave, and on the other side you have the trough, the downside of the wave. And if that trough hits first, that's when you get the pulling back of the water from the shore first. If you get hit from the crest side, you don't see that. And during the Indonesian earthquake that caused so much destruction back in 2004, we all remember the stories of in Indonesia where the water went away, and there was actually a whole lot of people that were saved by a little British girl who had just learned about this in school, and credits her geology teacher, where she saw what was happening and told her mom and dad, and they told everyone around them, and everyone ran, and they survived.
hmm,
But on the African coast, where they got hit by the crest side first, there was no withdrawing from the land, and
yeah.
they just got the tsunami.
And once again, right, that the that sort of in our mind and imagination is that big cresting wave, but it is, much more like someone just kind of took the earth or took the ocean, tilted the whole thing sideways, and then just the ocean just sloshes into the land. Like the water level just comes up and up and up and up and up and up, and it just pushes through the city, knocks over trees. It's not what you would expect, but it is as devastating as you can imagine.
And it's this combination of, you have a massive wavelength that can be kilometers wide, and as it approaches shore, it gets compressed, and everything in that wave, as it gets compressed, the amplitude goes up and up and up. And so what appears to be just maybe a meter increase, but then spread out over a vast distance, we don't notice that at sea. If you go up a meter or so for a long period of time, who's going to notice that except with GPS sensors? But you take all of that water and you compress it, and it's that taking that 1 meter higher out at sea and taking 1 meter higher spread over a vast distance out at sea and making it all of that 1 meter higher, becoming instead 100 meters higher over a shorter distance. Not really 100 meters. We don't really see that, but we do see 20 meters, 30 meters higher.
Right, but the point being that you don't see that big breaking, cresting wave. It's that the water comes in and it just goes higher and higher and higher, and fishing boats are plopped inland. And the best example of this is after the Japanese earthquake, the one that
2011.
yeah, the one that we
Japanese
just
earthquake.
had. There was a lot of cameras that were watching it, and so we got a chance to really see from sort of a bird's eye view and various views from on the ground just how the water level just kept coming up and up and up, like it was like, I don't know, like someone had poured water over the top of a bathtub, and then the water was just coming in and coming in. So for those of us who perhaps live in parts of the world which are at risk for tsunami, what should we be aware of? What should we do? How in terror for our very mortality should we be?
Well, first of all, it's important to realize it's not just an ocean problem. There are, and this is again something new I got to learn prepping for the show, which is part of why I love doing the shows. I learn new things. There are actually weather-caused tsunamis that can happen with the Great Lakes, with Lake Geneva, and other large bodies of water. This is where we have the atmospheric pressure will compress a large area of the water, and it's sort of like taking a big basin and just pushing down. It displaces the water and can cause its own kind of tsunamis. So if you're near any fairly significant body of water, you too may experience a tsunami. And what you should know is, what is your fastest route to get to higher lands? Now, you unfortunately are on an island. And if the Cascadia Fault goes, there is in the historic record, like, everyone on the island died. So have a helicopter handy.
Okay. I can go to higher ground. I got lots of higher ground all around me. No problem.
So knowing to go to higher ground is important. And one interesting thing to know about earthquakes is the longer they last, the higher the overall magnitude. If you have an earthquake that's over 4 minutes long, which is what they had in Japan back in 2011, you're looking at a magnitude 9. Magnitude 9 is everyone dies now, at least in the tsunami zone where it's going to hit. So if you have a subduction zone near you, so we're looking off the coast of Chile, off the coast of the American Northwest, there's one clearly off the coast of Japan, down in Indonesia area. If you're near a subduction zone, these are the ones that are most at risk of causing tsunamis because of how the fault lines slip. It's basically like taking a sheet, raising the edge, and just creating a wave, which many of us have done to smooth our sheets, except you're doing it with the ocean. And this kind of sudden displacement up and outwards that can occur with this kind of a fault slip tends to cause tsunamis more than the San Andreas Fault, for instance, which is slip fault side to side.
Right.
So know your kind of fault line. Pay attention to the weather. Pay attention to rocks falling out of the sky. Make sure you don't have anything that's going to have a massive landslide near you. We're looking at you, Scandinavia. You're the cause. Know your geology. And those of us living in the Great Flat Flyover states can rejoice. We are some of the only ones that aren't going to be affected by this.
What's that sound? Is that your tornado alarm going off again?
Yeah, I know. We get tornadoes instead. It's a trade-off.
Yeah.
It's a trade-off.
But so, as a person who does live in a tsunami zone, you are made aware of it. That, we drive out on the west coast of Vancouver Island, and there are tsunami regions where where it's very low lying. It's right on the Pacific Ocean, and the sign says when you are going into the region, and the sign tells you when you're coming back out again. And just in part of your brain is this thought like, okay, when I hear the tsunami, and there are alarms on the beach in the whole area, and their only job is to sound off when the tsunami happens, and then you in theory hop in your car and head for high ground. And we get tsunami warnings. I would say we get them every 5 years or so, that we get a warning, and it's always like there's one in Chile. We got a tsunami warning during the Boxing Day one that happened over in Indonesia, right? And the Japanese one too. So because those waves can cross, now they're not going to be as devastating as they are right next to it, but even halfway across the planet, you have to be careful. And there was one in Alaska that caused a tsunami to come right up one of the fjords on Vancouver Island, and took out the city of Port Alberni back in the 1950s. Super devastating, because it sort of concentrated the waves that came up this channel and wiped this city off the map on Vancouver Island. So we're made well aware of it. And the same thing if you ever have driven down the west coast of the United States. There's these low-lying areas in California and Oregon where there's the sign, and then it's very unnerving to be driving in this region where that should the tsunami happen, you've got to quickly book it to higher ground. It's a very interesting experience. So just for anyone who doesn't live in that, you are made aware. And I guess where I want to take this conversation next was just about warning systems, about how this is one of those natural disasters that now we have identified, and we do learn and we're able to kind of prepare a bit when one of these happens.
So it used to be that the Japanese, for instance, carved rocks to leave warnings because it was recognized that within about 3 generations, memories of these devastating events would start to fade. Parents would tell their children, parents would become grandparents, tell their grandchildren, and then the memories would be lost, and people would start building things where they shouldn't. So you see in Japan these literal standing stones where there's one that says, do not build below this point. And there are many that are commemorating the places that survived and the places that didn't. There are villages that have names that translate to things like Octopus Place, because that's where the octopuses were after the tsunami brought the octopuses into land.
Right.
So knowing the history and realizing that these things happen in this every several generations kind of iterative pattern is important. Knowing where I am now, do I need to worry? Knowing, is there a set of buoys that is going to be measuring between me and the other places that have these problems? After the 2004 Indonesian earthquake, it was fully recognized that our tsunami preparedness globally was not what it needed to be. There was not a sufficient set of buoys deployed in the ocean that allow us to monitor, thanks to the global positioning system, the subtle rises and sinking, the crests and the troughs that indicate there is displacement of the water. There is something we need to be aware of and prepare people to evacuate. There is an amazing Pacific tsunami warning system. They have a great website. You can monitor what all of the buoys are doing. But the question is it enough? Do we have enough of these buoys? Do we have enough sirens? Do we have a way to let people know? Japan has perhaps the most advanced system in the world because they are an island nation that has an entire history of dealing with this. And they've reached the point where they can give amazing warnings because information travels at the speed of light and earthquakes don't.
Right.
So once the earthquake starts to be detected in one place, they lock down the public transportation systems. They set off sirens to get people to hide under their desks and doorways, evacuate buildings that need to be evacuated. They send out helicopters to follow what's happening in the oceans.
Yeah.
The rest of the globe isn't so ready. And we never know. We're a world of subduction zones, earthquakes, and landslides waiting to happen.
I mean, with the modern age with mobile phones, I mean, I don't know about you. Does your mobile phone freak out when there's twisters in the area?
Oh yes, oh
Yeah.
yes.
Yeah. So and I've been traveling in the States. I was in Las Vegas and there was a flood warning and my phone beep booped at me. So I think that the level of communication now, in theory, if there was a tsunami coming our way, that all of our phones would all go off and everybody would be seeking higher ground. And anyone who didn't have a phone would have enough people around them with phones that they would be able to. But as you said, it's the people who are in places where maybe they don't have the detection system, they don't have the monitoring to know that there's a tsunami inbound. So
And we have to be careful of how vulnerable is our infrastructure. Several years ago, as you may remember, my husband and I accidentally drove through a tornado. I don't recommend this. We didn't mean to. It came out of the sky directly in front of our Jeep. We had nowhere to go. But the reason we were out driving in tornadoes is because the first thing the tornadoes destroyed was the building with the emergency alert system in it.
right.
So instead
They're
of getting
drawn
the
to
text
them.
message, yeah. So I didn't get the text message warning I would normally have received. And thus, stupidity occurred.
That's amazing. All right, well, thanks, Pamela. I don't know if our series will continue. I got a bunch of more topic ideas I want to pitch at you. So
And we will be doing fractals for episode 444 next week.
Well, there you go. Then I think destruction and rebuilding is at an end. We'll tackle fractals.
It's been a pleasure.
Yeah, and then we'll start again on why Pluto isn't a planet again.
Okay, that sounds great.
All right, thanks, Pamela.
Okay, bye-bye. Now don't actually go anywhere. We're just saving.
Yeah, that was for the audio listeners, not for you.
Save project and make sure Dropbox is not Dropboxing. So I don't know I saw people talking about a bunch of audio problems. I'm not quite sure where that was.
So at the beginning of the episode, my system was reporting that a ton of frames were getting dropped. In fact, they're getting dropped right now. I don't know whether that's, but I actually just rebooted my router seconds before I started the show. So wasn't that? I don't know. It was very stable then for the remainder of the show. And now it seems a little jiggly again. I don't know. I should have rebooted my computer. Carolyn B is saying, I have read that the 1607 flood in Bristol Channel, UK might have been a tsunami.
Yeah, and the thing we didn't bring up in the episode was actually Lisbon was completely destroyed in the 1700s by a tsunami. It's one of those things that's not quite at the level of the destruction of the Library of Alexandria, but it's not that far behind when you consider the amount of it was the King's Library, it was all of the peak of the Portuguese Empire architecture and artwork and all of Vasco da Gama's records of his explorations of the New World, all of it lost.
John Suffield asks, how much warning do you get for a tsunami?
It depends on if you're near it or far from it. Generally, for a lot of the subduction zones, we're looking at somewhere between 10s and 20s. That was a stupid phrase. Somewhere between tens of minutes and many tens of minutes for the nearest land.
Yeah.
And then it can be hours before it hits. So for instance, the tsunami that was triggered with the Cascadia fault in 1700, it was order of 10 hours later it reached Japan. These things are traveling at 500 miles per hour.
Yeah, we if one goes offshore from here on Vancouver Island, we've got about 10 minutes, 20 minutes warning at most. But when they go off in Chile or they go off in Asia, we get it's hours, 5-6 hours, and so we're
Yeah.
we're waiting. After we know the thing has happened, we're then waiting and trying to get an update, but we're not doing anything. We're just killing time, waiting to find out if it is something that we should be super concerned about. So
Yeah.
so absolutely.
And there's not tornado. There is tsunami warnings that go off 2 or 3 times a year. So just all along the West Coast.
Yep. Yeah. And where I am, I'm on the east coast of Vancouver Island. So
it would have to be bad.
We're essentially protected from most of those tsunamis. It would have to be one that goes off in between Vancouver Island and the mainland, and that would be bad. That would be very bad. Do we take out Vancouver? We take out us. All right, let's move on. Oh, that's right. I'm not supposed to say I'm trying to get rid of that vocal tick when I look for a new question and I always say I'm going to try and not say R. Jones says you can do an episode on dark galaxies or cosmic voids. Those are 2 different things. Cosmic voids we've done. So if you do a search, now we didn't. Sutter. Yeah, but we didn't title it that. So if you look in our archive, it's a conversation with Paul Metz-Sutter, and we mostly talk about cosmic voids, which is his area of expertise. And I've done an episode on The Guide to Space all about cosmic voids. Dark galaxies. I mean, we possibly the 3rd episode was dark matter. 4th episode, we covered dark matter.
But it's worth redoing it probably.
Yeah, it has been 8 years since we did the original show on that, and it might be time to talk a bit more about dark matter versus machos versus wimps versus Mond. So because of course the science is always changing, so maybe, and it might be a thing that I've been thinking about. I mean, the fractal, that was a joke about the Pluto, but it's not entirely a joke, which is that we could come back around, do other episodes on on topics we covered a long time ago, where the modern thinking is subtly different enough that I think we could just we could do dark matter version 2, black holes version 2, quasars version 2, etc., Big Bang, where some of that information is fairly new. So tell us if that's something we sort of have pigeonholed ourselves a bit, where
we'll have to redo the planets at some point.
Yeah, but we talked about black holes, and so we're done, right? We can never talk about them again. We did an episode on black holes. We're done. So anyway, just let us know if that's if you'd like us to come back around and tackle some of those really core topics again. That's a thing that I've been thinking.
Yeah, I'm thinking next winter we should probably redo the planets.
Sure. Run through the planets again now with the new observations from Cassini.
After Cassini has done its deep dive, because yesterday we learned that Pan is shaped like a ravioli.
Yeah.
And I want to find out what additional surprises does Cassini have in store, and revisit things now that Messenger has been to Mars and Dawn has gone to Vesta and Ceres, and we've had Rosetta at the impossible to pronounce comet. So redoing the planets, I think, is we know more. We know new things. This is why we do science.
Arjun wants to know, how are tsunamis monitored? Do they just give a warning when there's an underwater earthquake? How do they monitor tsunamis?
They have a series of buoys that they use GPS to monitor changes in position in, and there are set known patterns of movement that are like tsunami. So clearly you're going to get all eyes on those data pages the second there's a massive earthquake, but there is an automatic monitoring system out there.
Jason 93609, somewhat crazy question. Oh, sorry. How long would they... Okay, so if we had a spherical water world and propagated a wave on a localized source, would it look identical at the antipodal point? So the point is that if you had a water world, what would the waves look like as they propagated around? If you dropped a meteor into one side and then the waves were going to propagate all the way around to the other side of the world, to the antipode.
it wouldn't look the same where they started to it wouldn't the antipodal wouldn't be a mirror image because what you have is looking for things I can use as I don't have circular things. I have a circular thing on my desk and I have a turtle. Okay, we're going to go with the turtle and the circular thing. It's a turtle.
Turtles all the way down.
Turtles all the way down. So as these two, I'll go like this. As these two circular things approach, the waves start constructively and destructively interfering so that where the waves overlap on the crest, you end up with a bigger crest. Where they overlap on the troughs, you get a deeper trough. And so you end up with interference patterns where they start to overlap on the other side.
Did you ever watch Stargate Atlantis?
Mm-hmm. And it's turtles all the way down. I do need to say that.
Yes. Yeah. Did I say that? It is turtles all the way down. In Atlantis, they had, I believe it was a mostly water world. And so one of the ideas, I think, with having a very water world is that you don't have continents to slow down the weather systems. And so you would have winds that are pushing, waves that are growing, that would go all the way around the planet. Here on the Earth, you've got the continents that break up the waves, and anyone who's been out on the open ocean knows the waves are big. They roll. You can be going up and down 20, 30, going up 10 meters at a time on one wave. And if there were no continents, then the waves could just be getting bigger and bigger and bigger. So it's not tsunami, but it's definitely an interesting challenge on what it would be like, how habitable a water world would be, just because you'd have these enormous waves that are just going around and around the Earth, following the currents, right?
And as I said, you can end up with weather-driven tsunamis just from the air pressure on the water.
Richard Strazel asks, are there any signs of tsunamis on Titan? And I guess that question would be, do we see any place in the rest of the solar system where we might have tsunamis?
I don't think we have the right kind of data of Titan yet to be able to answer that.
But it's an amazing question, because you've got Titan, and instead of water, you've got oceans and lakes of hydrocarbons, of methanes and ammonia acting like water.
Yeah.
There are waves.
That's something that if anyone could answer, Planet Doctor Sarah Horst could answer, and so I'd ask her that on Twitter.
Yeah. Would you get landslides of water ice falling into oceans of ammonia causing tsunamis? It's a crazy concept. I love the question. So thanks, Richard. That was mind-bending.
Yeah.
John Drake is asking, how many waves from a single meteor strike? So if you get that strike, how does it propagate outward? Do you get multiple waves?
You generally get multiple waves, and I think it's going to depend strictly on the shape of the floor, the shape of the shore, and the amount of energy in the strike. Just how many waves you end up with.
Hilal Avron asks, Fraser, are you up to speed on The Expanse? This season is blowing my mind episode after episode. I am up to speed on The Expanse.
I'm not. No spoilers.
Loving it. And it's only 2 episodes ago where the werewolf from Being Human, the American version, explains or demonstrates how they have a really fancy propulsion system, and that explained what I consider to be big scientific problems in the show. So for the first season, I was like, oh, there's a lot of problems with the way they're doing the science, how sometimes they have gravity and other times they don't have gravity. But it turns out they have a sort of a magical MacGuffin propulsion technology that lets them thrust at 10 Gs or 1 G for periods of time. So zipping around the solar system in this show, and I guess book, is a lot easier than it would be in the real world. The Epstein drive. But overall, it's an absolutely terrific show, and I really enjoy it. And if you are a fan of space and you're a fan of television, there is 2 great tastes that go great together. I would say it's the most realistic portrayal of space exploration and colonization of the solar system that has ever been shown on television. On the scale of not as good as, say, The Martian or 2001, but better than anything else that's been ever shown on television. So and the story's fun and entertaining, and the Belters on this, the people who come from the asteroid belt, they have their own accent that they invented, and so everyone who comes from the belt speaks with this accent, which is really great. I really enjoy it. It's a good show. Watch it. Susie is saying, I had to devour the Expanse books. I couldn't wait for the show.
Fair. You look perplexed.
Just looking for questions.
Okay. So folks are asking if the phone warnings are built into the operating systems of devices for tornadoes and tsunamis and things like that. I don't actually know. I think they probably are part of in the United States, the emergency broadcast system, where we do have, thanks to the Federal Communications, FCC, I don't know what the second C is, various requirements for national safety built into how things are communicated. They go off here for what are called Amber Alerts, which are alerts that a child has been abducted. Silver Alerts, which is when a senior person has wandered off and needs assistance. And then, of course, for emergency weather events. So far, we haven't had any emergency earthquake events since this system has been in place, as far as I know. Some people in California might correct me.
Well, like I said, I've been in Vegas when there was a flood alert, and it was red. Everything was red.
And your phone starts making a klaxon noise that has no correspondence to the volume setting on your phone. And you get a black box alert if you're on an iPhone, and I think it's the same on an Android, that says in white text what is going on.
And it happened to everybody.
Yeah.
So I was
if you're
on
in Target, oh my gosh.
Yeah, I was on a train, on a monorail in Vegas, and so we were all stuck in this same train car together, and all of our phones went off simultaneously. And then everyone was like, "What?" And everyone was like looking at their phones. And then we were talking about the flood warning that was happening. It's great that this system exists and that it actually does this job. This is a level of communication and awareness that wasn't possible back in the olden days. So
it does occasionally make you want to fling your phone. We had 1 thunderstorm and 2 tornado alerts a week ago. The night before I had an early flight, and I'm glad to be alive. I still wanted to hurl my phone out a window.
Tony Phillips says, seriously, there don't seem to be tsunamis on the east coast of the U.S. Are they still possible? Are the east coasters
they're always possible, but the difference is it's not a subduction zone on that coast. So off the Pacific coast, you have a plate diving under a plate, and this causes the kind of earthquake that triggers tsunamis. In the Atlantic Ocean, we have basically England and America moving apart from one another. We have this great mid-ocean trough that is filled with volcanoes and is slowly building new land as things divide. And while there are earthquakes associated with them, they're just a different kind of earthquake. Now, don't forget Lisbon. Lisbon got fairly destroyed.
Right.
And that was the zone off the coast of Lisbon.
Arjone asks, what would the tides be like on a water world, for example, in the TRAPPIST-1 system, since they're tidally locked but perturb each other? Right.
I don't know. I just don't know.
Yeah. This question's come up a couple of times, and I haven't chase this one back to the source yet, but I understand the concept that you've got the TRAPPIST-1 red dwarf star, you've got the worlds, and they are tidally locked to their star, but yet these worlds are still orbiting around each other, and they're very close, and they are Earth-sized worlds that are Earth, much, much closer to each other than, say, we are
Yeah.
to Venus or any of that, right? Like,
It's more like the Jovian.
it's more like the Jovian systems, and so they're going to be interacting. And so as these planets go past each other, they're going to be pulling water blobs around. The tides would be so weird. So I do think that's something I'm going to need to dig into and try and wrap my head around.
There's
Maybe we'll do
going
an
to be
episode.
someone doing simulations.
Yeah, we'll try and do something on Universe Today about that, because it is a pretty fascinating question. The interesting part about this is just the more the research that comes out, the more and more people are saying, take that idea of habitability with a grain of salt, that you do not want to live on one of these worlds.
Yeah, it's true.
Yeah.
It's
poor
very true.
aliens. Well, I think we're at the end of our time here.
I think we are.
Let's see. Physics Police is saying the TRAPPIST-1 worlds wouldn't have held on to any of this water that long, would they? Do we know? I mean, that's a great question, right? We don't know. It's a red dwarf star. They are in the danger zone from a red dwarf star that is blasting out mega flares, or has blasted out mega flares in the past.
But water comes back. We were baked dry. Our sun did that to us. Our mean, angry, young sun baked us and the other inner worlds bone dry. And then the water came back because of impact events. There may have been internal water trapped. We're still trying to sort that out. Caveat, caveat, caveat. But because of impacts of objects that have a large moisture content, you can re-wet something.
Right. So we could have a situation where the planets were under this horrible mega flare zone, baked dry, all the water was blasted away, and then over the next few 100 million years, comets and other objects still in the solar system maneuver back in and deposited material back onto these worlds, right? Okay.
Yeah.
Okay, well, let's wrap things up. Hey, Pamela, thanks for bringing the brain this week. Thanks to everybody in the chat for watching. If you want to know how to join this down here, that is the Slack chat. Just go to wshcrew.space, join the community for both Weekly Space Hangout and here on Astronomy Cast. The hope within the next couple of weeks is that we're going to turn this extra show into a podcast as well, so that if you don't feel like you can show up and watch this episode live with us, or you just prefer to get your knowledge through your podcasts, through your earballs, that's what we're going to try and make possible for you. That's me. Like,
I'm an earball person.
Yeah,
myself.
I really don't like to, I enjoy YouTube videos, but I don't think to watch them all the time. And a lot of stuff, I mean, obviously we're very pretty to look at, but you can just listen to us on.
I'd rather you listen to me.
But yeah, so I think that's going to be cool. And I feel like the after show has evolved into its own creature, and it's quite entertaining. So
I enjoy doing it. I have to admit that. I
do too,
love that you're all here asking us questions, and it's a blast.
Yeah,
so thanks
totally.
for coming and poking at us with cool creative things.
Fantastic. All right. Well, thanks everyone for watching. Thanks, Pamela, for bringing the brain. We will see you all next week.